Welcome to another edition of MatHAMMatics. The other day I was working with some students trying to help them understand how to factor when the value for a is not equal to 1, and all of the other methods that I had tried showing them just weren't clicking. And so I went home and I was stewing on this for a while, thinking about two problems in particular. And for whatever reason, this idea came to me. It's not something I've ever seen before. Certainly not going to claim that I've invented new math, but I hope you enjoy a new way of factoring. As long as I've been teaching math, factoring when the a value isn't 1 has been a struggle for many students. And so we've worked through this idea of learning how to take what we call the target product, taking the a value and the c value and multiplying those together, knowing that the two factors built by your binomials come from the factor of these, right? 2 times 15 is going to give us 30, that produce a target sum, which is that b value in the middle, the negative 11. And so borrowing from magic X concept or any structure that you like to organize thoughts, we got to think through what multiplies to make 30, adds to make negative 11. And so we can think through our different factors of 30 and come up with negative 5 and negative 6. Now here's where things get a little different, because we've used this initial strategy for most of the factoring that we have taught. For a lot of my students, they want to take those two values and they want to simply plug them in to the binomial sets. They want to take the negative 5 and shove it in at the back of the first one and that negative 6 and put it in the back. But of course, we know that negative 5 times negative 6 is not going to yield us the 15 that we have at the end of our trinomial. So what if we were to allow this, but make our factors heavy by a factor of a? Plug that 2x into both locations. In doing so, we know that we have too much a in there. Our factor is heavy by a factor of 2. And so we can finish multiplying by 1, since we multiplied by 2 to start, by dividing by 2 to finish. And so we can look at our two groups and say, well, it doesn't make sense to take 2 out of this first pairing. There's no GCF there. But if we look at the second pairing, there is a GCF, and that GCF is 2. If we divide it out, we have our factors for 2x squared minus 11x plus 15. Now, what if a is a composite number where there's multiple combinations, right? 2x and x was relatively straightforward, but what about this one here, 12x squared plus 8x minus 15? Well, we want to start in the same place, right? Still find our target product and our sum, so take the 12 times the negative 15, to make that add up to 8. 12 times negative 15 is negative 180. So what multiplies to negative 180 adds to 8. Got to be negative 10 and 18. So let's try it again. So create our factor pairs, shove the negative 10, the negative 18 in, and then toss in 12 x's in both places. From here, be guided by our GCFs. For 12x and for negative 10, 2 is the greatest common factor, so divide that out. 12x minus 18, the greatest common factor, 6. Divide that out, and look what happened. The two GCFs that we divided out account for the a that we added in value. And so we've taken care of the multiply by 12 by now dividing by 12, giving us the factors of 6x minus 5 and 2x minus 3. Now, if you already know how to factor and are comfortable with the method, then this is probably not for you. This could muddy the waters a bit, but for a lot of students who struggle, this might be one of the quickest ways I've found for them to be able to figure out in a mathematical way the factor pairings for much more complicated problems. So, hope you enjoy.